Inês. So today we have Inês Xavier from Pompeu Fabra about to join the Federal Reserve Board. Inês, thank you very much for accepting our invitation. You have an hour and 15 minutes. Take it away.
Thank you, Ivan, and thanks again for having me here today. Obrigada. So I'm going to be presenting this project, which is broadly just trying to understand how can we understand the high concentration of wealth that we observe in the United States. And so the starting point for this project is the observation in the data that wealth is highly concentrated in the US, and in particular, it's substantially more concentrated than labor income. So this is exactly where I'd like to start and what this graph is showing. So for example, let me focus your attention first to the blue bars in this graph. So the blue bars are representing what is the share of wealth that goes to different groups of the population. So for example, the way to read this is to say that, for example, the richest 1% in terms of wealth in the US, they own a total of 37% of the total wealth. Or for example, if we were to look at the richest 10%, we would sum up these bars here, and we would see that the richest 10%, so just 10% of the population, own a total of 76% of the wealth. So this is data from 2019. So this is, a high degree of wealth concentration. And then if we compare the blue bars with the orange bars, which are representing the distribution of labor income, then we can easily see that despite the fact that labor income is also concentrated, labor income is less concentrated than wealth. So again, for example, looking at the top 1% labor income earners, they receive about 14% of the total labor income, which is still a substantial degree of concentration, but clearly less than the degree of concentration in wealth. I start with this comparison because the fact that wealth is more concentrated than labor income is at odds with the predictions of the simplest, most standard model of wealth inequality. And these are models where the key source of wealth concentration is labor income inequality. And I say that this is at odds with the predictions of those models, essentially because the literature has proposed different versions of those models where individuals have different labor incomes and then they accumulate wealth over time. And these models have tended to find that the ability of these models to generate wealth concentration seems to fall short of the amount of wealth concentration that we observe in the data. And even more than that, these models have more of a theoretical prediction, if you will, and that prediction is that the right tail of the wealth distribution cannot be fatter than the right tail of the labor income distribution, which in a sense is saying again that in these models, wealth cannot be more concentrated than earnings, which is clearly at odds with the first graph that I showed. So these observations have suggested to the literature that there are likely other forces playing a role, potentially generating wealth concentration, and that we should try to understand them. And exactly what I'm going to do in this project is to try to understand a little bit better one of those forces, and that is this heterogeneous returns to wealth. And essentially what I'm going to try to explore is the possibility that besides potentially receiving different labor incomes, individuals, when they save over time, they may receive different rates of return on their wealth. And so then this potentially is an additional source of wealth concentration over time because some people accumulate wealth faster than others. More precisely, what I'm going to be doing in this paper is, I'm going to start by investigating the degree of return heterogeneity in the data. So I'm going to try to understand how empirically relevant this mechanism is. And to do this, I'm going to be exploring data from the US Survey of Consumer Finances, which covers a period of 30 years. And so I'm going to provide some empirical evidence of return differences in the data for the United States. And by providing this evidence for the US, I'm going to expand on some recent literature that has provided some evidence of return heterogeneity for Scandinavian economies based on administrative data, which unfortunately we don't have available for most countries. Then after documenting the degree of return heterogeneity in the data, the second thing that I'm going to try to understand is get a sense of how quantitatively important these return differences are as a source of wealth concentration. And to answer this question, I'm going to propose a partial equilibrium model that features two key sources of wealth concentration, which are on the one hand, labor income differences, and on the other hand, I'm going to include also differences in rates of return to wealth, and I'm going to impose that the model matches the return differences that I document in the data, and then I'm going to come up with an answer, a quantitative answer of how much this mechanism matters. So if there are no questions yet, then let me just give you a quick preview of the findings. So
Inês, this is Rogerio. I'd like to make a question about the chart with which you started the presentation.
Mm-hmm.
I wonder whether this concentration of wealth has been aggravated by the very sharp fall in interest rates through a capitalization effect. Do you have this chart for many years so that you could somewhat associate the fall in interest rates to the aggravation of this concentration rate?
Yeah. So thank you. So that's right. So that's a good point. Indeed, if you look at the data for the US, so this data starts in '89, and if we look at that data, we do observe somewhat of an increase, well, both in aggregate wealth, but also in top wealth shares. And then there is some literature linking that to falling interest rates and just trying to understand whether the evolution of asset prices, at least in part, simply reflects that fall in safe rates. So here in this presentation, I don't have a graph ready, but so you could see that. In this paper, I'm not going to focus on the dynamics of wealth over time. So I'm not going to be trying to address why is it that wealth shares have increased somewhat, at least in the past 20, 30 years. But I'm going to focus more on the question, kind of on a level question, which is to say, on the long run level of inequality, I'm going to compare a world, let's say, where individuals receive an identical rate of return on their wealth versus a world where they potentially receive different rates of return. And I'm going to compare the long run level of inequality implied by these two different worlds. But yeah, that's right. Thank you.
And Inês, are you going to look at the fact that rich people tend to save a larger fraction of their income? Because this could be, even with equal returns for everyone, if some people save more, they'll be wealthier.
Exactly. So I guess, so in the model, so there are going to be two reasons for people to save at different rates. So one is going to be the labor income, the labor income uncertainty, and the other is going to be the different rates of return. So, I mean, this just to say that I guess it depends on each exactly definition of saving rates we're talking about. But so beyond these two mechanisms of different saving rate, different labor incomes and different rates of return, there's not going to be any additional heterogeneity, in particular in preferences. And so that's not going to difference in saving rates beyond the endogenous effect of different labor incomes and returns. I'm not going to have in the model. Okay, and what I'm going to show is that the differential behavior that comes, the differential saving behavior that comes from different labor incomes and different rates of return, that itself can already generate a wealth distribution and an amount of concentration that is very close to the one that we observe in the data.
Right. I don't know if you know the recent paper by Mian and Sufi. They have and Schwab. They have non-homothetic preferences precisely to get different saving rates out of, like to have marginal propensity to consume out of wealth, not out of transitory income. And they can show also that it explains, because there are indeed big differences between like saving rates across the distribution. But I guess, all these effects are going the same direction.
Yeah, I mean, I guess, so one other way that this literature has proposed to, in order to generate difference or wealth concentration, is to have non-homothetic preferences. Right. So what this implies is that richer individuals are going to save relatively more, and then so the tricky part there is to measure these preferences, or to measure this non-homotheticity. Typically, the models then they allow for this non-homotheticity, and then they target top wealth shares in order to back out what is the degree of non-homotheticity that we need. So yeah, that would be, let's say, an alternative way of generating wealth concentration. In this model, I'm not going to have that. Yeah. Okay. Thanks. So as I was saying, just to give you a very quick preview of the findings of this paper, the first one, it's empirical, and so I'm going to be documenting that that there is return heterogeneity in the data. And in particular, I'm going to find that as we move towards the top of the wealth distribution, the average rate of return that households receive on their wealth increases. And these differences can be large, and especially as we go to the model, we see that they can have important implications for the distribution of wealth. The second main finding is that once we take into account these return differences in an otherwise standard model of labor income inequality, when we calibrate this model to the data, then this model is able to generate substantial wealth inequality, and in particular, much more wealth inequality than a model where returns are homogeneous. And so in particular, this model that features both labor income and return differences, this model is going to be able to generate an amount of wealth concentration that is extremely close to the one that we observe in the data.
Yes, just a short clarification. The earnings inequality measure includes capital gains?
The earnings or returns?
The returns. So, the return heterogeneity includes capital gain?
Yeah, so I'm going to be, I think perhaps it's going to be clear when I explain exactly the data that I have, but essentially, so I'm going to be considering capital gains as one part of the return to an asset. But then in terms of differences across the wealth distribution, differences in capital gains are going to appear when individuals own assets that earn different capital gains. So for example, if some people own houses and others own equity, but then within these broad asset classes, I'm not going to have any differences in capital gains, again, within asset classes.
Okay.
But yeah, I'll discuss it in a few slides.
Okay, thank you.
Thank you. Okay, so let's dig a little bit deeper. So let me start with explaining exactly what is the data that I have. So the data that I'm going to work with, the main source of data is the Survey of Consumer Finances, which, as I said, covers a period of 30 years from 1989 to 2019. And this is a survey that is done every 3 years and has information on a cross-section of US households on their income, their assets, and their liabilities. One nice thing, just one small comment, one nice thing about the Survey of Consumer Finances relative to other surveys is related to the fact that there is an oversampling of wealthy households which is a nice thing to have because wealth is so concentrated that most likely if we were to just collect a random sample of US households, we would probably not have a very accurate picture of the small group of individuals that own a disproportionate amount of wealth. But anyway, so I'm going to have information on US households' income and wealth. And for example, just to give you an idea, in terms of income, data is quite detailed in the sense that I'm going to have information on whether the income that households receive, whether it came from wages, whether it came from dividends from the ownership of stocks, whether it came from profits if households owned any businesses, and so on. And in terms of the wealth information that I have, so as I said, I'm going to have information on both assets and liabilities. And more specifically, I'm going to group assets and liabilities into these broad categories. So there's going to be an interest earning assets category. So this is going to be mainly transaction accounts and bonds. Then I'm going to have an asset class called public equity. This includes the ownership of stocks, both directly or indirectly through mutual funds, for example. Then I'm also going to have information on the ownership of private businesses. So these are businesses that are not publicly listed. I have the value of real estate, both the primary homes where households live and potentially other secondary real estate. Then there are two more residual categories of other financial and other non-financial assets. And finally, there's going to be one class that I'm going to call debt that includes all type of debt that households may have. And the definition of wealth that I'm going to work with is, so wealth is going to be defined as the difference between gross assets minus liabilities. So this is what I mean by wealth. Okay, so the goal, or one of the main goals, is to estimate the return on wealth. So let me clarify what I mean by that. So the rate of return on wealth, RW, is going to be given by the weighted average of the return on the different asset classes that comprise wealth, RC. And in turn, this RC, this rate of return on each asset class, is going to be given by two components. A yield component, which reflects the dividend income generated by an asset, for example, dividends from the ownership of stocks, and a capital gain component that reflects fluctuations over time in the price of the asset. And so this, I'm going to take into account these two sources of income relative to for each asset class. Okay, so the Survey of Consumer Finances is going to have information, or enough information for me to directly estimate the yield component of returns. In terms of capital gains and losses, so the Survey of Consumer Finances does not distinguish between the physical quantities of the assets, or so when I see changes in the value of the asset, I cannot disentangle what are fluctuations in the quantity of the asset versus fluctuations in the price. So I'm going to use aggregate price data by asset class in order to impute these capital gains by asset class. And so that's what I mean by, so I'm going to when I measure capital gains, I'm going to measure them at the level of these broad asset classes. So I'm not going to capture any differences in capital gains within each of these asset classes. Okay, so starting with the yield component of returns, or the dividend component. So very broadly, you can think of the yield component of returns as the ratio of the net income generated by the asset to the value of the asset in the beginning of the period. So what I'm showing here is how I estimate the yield component of the return to any given asset class over the 3 periods that separate the 2 waves of the survey. And here I'm giving the example of the survey. There is a survey in 1989, there is a survey in 1992, and I'm going to try to estimate the return of a given asset class over this 3-year period. So I have information on the value of the asset in the beginning of the period, and I'm going to estimate the income generated by a certain asset class by using information that households report in these two different periods of time. But anyway, I think the important thing to just to keep in mind is that broadly the yield return is just some measure of the ratio of net income to the value of the asset. So first, starting by doing this for the aggregate economy. So here I'm still not looking at how returns vary along the distribution. Here I'm still looking at the aggregate economy. So computing the yield component of returns for each of the asset class, we obtained the estimate that is here in the third column of this table, which shows that there are substantial differences across asset classes in the dividend return that the assets yield over this period. So this is the average over the whole period. And now, having the yield component, the second thing that I'm going to do is to also estimate the capital gain. So as I said, here I'm using external data, and in particular for public equity and for real estate, I'm going to use Schiller's index to estimate the real capital gains and losses over the period. And for private businesses, I'm going to use information from US financial accounts. So what we see here is that, well, in terms of just the capital gain component, equity earned higher returns than the remaining assets, and in particular, higher returns than real estate over this period. Where, for example, so this is the average over time, but if you were to look at during the whole period, we would see that well, as we saw the real estate boom and bust during the 2000s, we would have observed this as well. And we observed that when the real estate bust happened at the end of the 2000s, then the price gains that were accumulated in the first part were almost destroyed or canceled. Anyway, so the object that we're looking for is the total return on each asset class. And so what I'm going to do now is putting together the two components, the yield component and the capital gain. And so the resulting estimate is the one that you see here in the third column of this table, which is showing what was the average rate of return for the aggregate US economy by each asset class. So here, I'd like to make 2 points. The first one is that we see substantial differences across asset classes in the average rate of return. And in particular, we see that equity and private businesses especially earn substantially higher returns than either real estate or interest earning assets.
Sorry, I have a question. Public equity is what exactly?
So public equity are publicly listed stocks.
Okay.
So yeah.
So they are separate from private businesses.
Exactly. So if they are not publicly listed, they would be, so these are firms that are not publicly listed. Those would be private businesses. If they are publicly listed, they are included in the public equity category. So as I was saying, so there are substantial differences across asset classes, and we do see that equity earned higher returns. And the second thing also that I wanted to say was that, okay, so given that this is the rate of return, or at least the average rate of return on each asset class, if we were to weight them by the share of each of these asset classes in total wealth for the US economy, if we were to weight each of these returns by the weight of each asset, then we find that the aggregate portfolio of the US economy earned a rate of return of 6.8% a year on average over this period. So given that this was the aggregate rate of return, if you want, the question that I want to ask now is whether we observe that over this period, whether it's fair to say that most households earned a rate of return close to 6.8% a year, or whether there were substantial differences in this rate of return. So what I'm going to do now is to kind of repeat these calculations. So repeat the calculations of the rates of return on wealth, but now I'm going to be focusing on smaller groups within the wealth distribution. And what I'm going to find is this graph. So when I compute the average rate of return on wealth for different groups along the wealth distribution over this period, what I'm going to find is that the average rate of return on wealth tends to increase with wealth itself. So as we consider richer and richer households, the average rate of return on their wealth increases. And these differences can be large, at least intuitively, if we compare, for example, households in the 20th percentile with households in the top 1% of the wealth distribution. We see that there is a 4.7 percentage points gap in their yearly rate of return on wealth.
So Ines, this is because richer people own stocks basically, and stocks from private and public companies, right?
Okay, so that's a good point. So this brings me to the next slide. So if let me address that. So one thing that we can ask is precisely that. So is it the fact that people just own different assets? So can we explain the return differences by that? And so here, what I'm plotting is how the asset portfolios look like along the wealth distribution. And I guess in line with, I think what you had in mind is the idea that wealthier people own a relatively larger share of their asset portfolio in the form of equity. And in particular, as we move towards the very top of the wealth distribution, a large share of their wealth is owned in the form of private businesses. And I just said that these assets earned, especially private businesses, earn substantially higher returns than real estate, which is the main asset of households in the middle and also somewhat at the bottom of the wealth distribution. So I don't know if you had any.
But that's the only effect, right? Because you don't have within asset class heterogeneity. So all the heterogeneity in return comes from the composition, right?
No, okay. So in terms of the heterogeneity in returns, it comes from either from owning different portfolios, as you said, but also on the yield component of returns. In that case, it's possible that the yield component, that the yield return, the dividend return, is different within asset classes. Okay, because I have information on, say, the dividend generated by stocks, by the ownership of stocks, and so I compute the ratio of dividend to the value of the asset, and potentially, if this ratio is different for people along the wealth distribution, this is going to be
okay. So you have some degree of heterogeneity within asset class, and
exactly.
One thing I was wondering, many people from the bottom 50, let's say, they actually own stocks, but indirectly because they, through their pension scheme. So actually, they do not. So are you counting this future wealth, like people's retirements?
That's right.
Accounts.
Yeah. So this is another nice thing about the SCF is that it has information on defined contribution pension plans, and that it's true that the majority of stocks owned by middle-class households is through their pension plans. And this is going to appear here also in this okay. Well, in this data and in this graph, yeah.
Yes, Walter speaking. Are you concerned about the reliability of the earnings of private businesses? So do you expect any bias in direction?
Yes, so that's a great point. So I guess one question is, so when I compute the profits or the return to private businesses, so broadly thinking of the ratio of profits to the value of private businesses, I guess the question is whether, it could be the case that I would be, say, overestimating the return on private businesses of the very rich, if it was the case that the rich, let's say that they report their profits accurately, but they underreport their private business well. Or if they were to, somehow there was any clear bias in the reporting of either profits or the value of private businesses. So the one thing that one could check is first how the SCF compares with other administrative data in terms of income, in capital income, and in particular in private business income. So if we compare the income reported in the SCF in terms of private firms, but broadly in capital income with the administrative data, it lines up very well. So it's actually very consistent with other sources of data. In terms of the value of private businesses, very broadly, also in terms of trends, so there is no administrative data on wealth, but we do have data from, for example, US financial accounts. The information, the value of private businesses in the SCF lines up well, especially until 2004 with US financial accounts. But then, if anything, is a little bit higher in the survey of consumer finances. Since this asset is very much concentrated in the hands of the rich, if anything, I would think that this implies a relative, I mean, if it were the case that the rich over-report the value of their private businesses, this would lower their returns. But so this just to say that there is no clear, I mean, also this is an asset that is, as you see, also very concentrated among the rich. So it's not like there's a lot of ownership of private businesses at the bottom of the distribution. But in any case, there is no clear evidence of bias in the way in which, say, middle class and rich people report their businesses. If anything, it might be that the value of private businesses is a little bit higher in the SCF relative to other sources, which would actually lower the return of private businesses in the SCF. But I would say that broadly, the evidence that we have for the SCF in terms of the valuation of these assets is consistent with external sources, either administrative data or data from financial accounts.
And sorry, Inês, just following this question, private businesses, these are mostly like, what's the mostly big companies that are not publicly listed, or it's all the small businesses in the country? Like, what's the...
No, so these are, I mean, in principle, there is no limit in terms of the amount of employees or the size of these firms. So they should be included. There is a lot of heterogeneity, but actually most firms are not very large. So those typically are they are smaller, much substantially smaller than the publicly listed firms.
So these are going to be, often the rich are going to be the business owners, like the entrepreneurs, right? Because like if these are small companies, it's hard to it's hard to buy the shares if you don't know the company or the person. Like, that's what I mean.
So these private businesses, they count as private businesses owned. So all of the people that report, they are going to be the owners. Then if you want to think of entrepreneurship, another thing that one question that is asked in the SCF is whether the owner also works and actively manages the firm. And perhaps there you can think more directly as these people as the entrepreneurs.
Inês, I have a question about the way you treat pension funds. You take pension funds into account, but different pension funds have different portfolio allocations. How can you map different portfolio allocations to individual families?
Yeah, so thanks. So the SCF asks about the composition of these funds. So typically, so when this information is given, then there is this adjustment. So the computation of the returns takes into account the composition of the portfolio of these funds, or otherwise it's imputed. Sometimes 50-50, say bond and stocks, whenever this information is not given. But so there is information about that.
Inês,
Okay,
just
so
out of curiosity, the very large participation of other non-financial for the second decile is what? Old cars, things like that?
that's right. So it's mainly cars.
Okay.
Exactly. So this large share, you can think of it as something divided by something that is very small. So these are people that have very little wealth. And yeah, this main other non-financial asset is vehicles. Okay, so as Ivan was hinting, so the one important source of the return differences that we saw in the previous graph is coming from the different composition of asset portfolios and the fact that wealthier households tend to own assets that earn on average higher returns. In particular, they are more exposed to equity. And especially at the top, they are very exposed to private businesses. But in addition to that, so when I look at when I look within asset classes, I also find some evidence of return differences. So suggesting that beyond the effect of heterogeneous portfolio composition, there seem to be additional differences in returns, and that even within asset classes, returns tend to increase with wealth. So this is going to be particularly true for the case of real estate when we compare the very top of households at the very top of the wealth distribution with the remaining households. And it's also going to be the case for private businesses, although here this is not monotonic, but still on average, if we look at the top 10%, they tend to earn on average higher returns than households in the next 20%. Just one simple exercise where I try to get a first sense of the relative importance of these two stories. So the portfolio composition versus return differences within asset classes. So here in this graph, I'm showing two counterfactual rates of return besides the actual rate of return in red. So the first counterfactual is what I call the homogeneous portfolio, the green bars. And so here what I'm doing is I'm saying, let me allow households to potentially receive different rates of return on their wealth within asset classes, but let me impose that everyone owns the aggregate wealth portfolio. And so here I'm eliminating all differences in portfolio composition. And so what would this mean is what I would be saying, let me impose that households at the bottom and also at the middle of the distribution, let me impose that they own relatively more equity. And for households at the very top, I'm going to be substituting equity by real estate or interest earning assets, essentially. So what this would do, so this would give me these green bars, which would mean, so not surprisingly, this would raise returns for households at the bottom and at the middle of the distribution, and it would lower returns at the very top. Still, there would be some additional remaining differences between the bottom and the top of the wealth distribution. If instead, the other counterfactual that I have here is the blue bars, where I'm saying instead, well, suppose that households own different types of assets, so there is some portfolio heterogeneity, but let me completely eliminate differences in rates of return within asset classes. And here, so this would give me these blue bars, and this would increase substantially rates of return at the bottom of the distribution, and it would again lower returns at the top. So here, I mean, so this is a kind of a partial equilibrium exercise. So here what we see is that, so remember that these households at the bottom, they are very much exposed to real estate. And here what I'm imposing is that they earn the aggregate rate of return on housing, which is higher than the rate of return that poor households receive, because as I showed in the previous graph, poor households own lower returns on real estate than richer households. So essentially, I'm just saying, I'm imposing counterfactually that these households own higher returns on their housing than they do. And since they are very much exposed to this asset, this raises their rate of return a lot. Again, important differences would persist, especially between households in the middle and in the top of the distribution, suggesting that the additional differences in portfolio, so the additional differences in portfolio composition are still important. So this was just a simple exercise, but essentially it suggests that broadly the two sources of differences in rates of return, both in portfolio composition and in return differences within asset classes, are the two are important to understand the overall return differences that we observe between for households at the bottom and at the top of the distribution. So let me briefly take stock. So so far what I've shown, the data that I've discussed, is suggesting that there is substantial heterogeneity in returns to wealth. And in particular, I've shown that the average return on wealth tends to increase with the household's position in the wealth distribution. I've discussed two more immediate sources of these return differences. The first one is the fact that wealthier households tend to own relatively more equity, which earn higher returns than real estate, which are the main asset of households in the middle and also somewhat at the bottom of the distribution. In addition to that, I also documented some additional differences in rates of return within asset classes, here coming from the yield component of returns. Okay, so given these return differences, I'm going to move now to the second part of this project, and the second question, which is to try to understand how quantitatively important these return differences are to understand the high degree of wealth concentration that I documented in the very first graph. So what I'm going to do is broadly amend the workhorse model of labor income inequality, and I'm going to include as well differences in rates of return to wealth. And so the basic building block, if you know this type of models, is going to be the Bewley-Hayagari type of heterogeneous agent model. And what I'm going to add to this basic building block is this return heterogeneity, where the goal is to introduce heterogeneity in such a way that I match this positive correlation between returns and wealth that I observe in the data. I'm going to be more precise also when I jump to the model, but the way I'm going to generate this positive correlation is going to be by introducing some return risk. So return risk is going to introduce some heterogeneity in rates of return. And in addition to that, I'm going to introduce return types. And so these are going to be more permanent differences in rates of returns across people. But I'm going to be more precise in a second. Okay, so the setup of the model is the following. So the economy is going to be inhabited by a continuum of individuals indexed by I, and they are going to maximize expected lifetime utility from consumption. And in terms of the preferences, I'm going to assume standard CRA preferences, where gamma is going to be the parameter that governs relative risk aversion. Then individuals are going to save and accumulate wealth, which I denote by A, over time, according to this equation. So notice that in this model, I'm the only, so there's only one asset, this wealth A. So I'm not going to have an endogenous choice of assets. And so the law of motion of wealth is going to be given by this expression here, which says that the change in wealth holdings is going to be given by the difference between total income and consumption, where total income is the sum of a labor income component and a capital income component that potentially reflects differences in this rate of return R. finally, individuals face a borrowing limit that prevents full consumption smoothing. Again, here, this is as simple and standard in the literature. Okay, so the labor income process that individuals face. So here I'm going to assume that labor income is stochastic, so individuals are going to face labor income risk. And this process is going to be described by a stationary diffusion process, where here I keep it general, but I'm going to later make some assumptions on the form of this process, in particular on the mean and the standard deviation of this process. But here, essentially, this is just saying that labor income is going to be stochastic for each individual. In addition to that, there's going to be, so returns are also going to be stochastic, and they're going to follow as well a stationary diffusion process, where this function mu r is going to determine, again, the mean of rates of the return process. And this function sigma r is going to determine its standard deviation.
So here, just a quick observation, seeing how you treat labor income. One problem is that you are leaving aside human capital returns. I see people have assets, but people also have human capital. And perhaps that explains part of the difference between the distribution of income, distribution of wealth.
But so you mean some form of human capital that is not captured by the returns to labor?
It's not captured in the wealth of the individuals. Human capital is part of the wealth, in a sense, and you are not capturing that.
But that would appear in the wage.
That's not a criticism. It's just an observation. And shouldn't you take that into account in how you treat labor income?
I mean, so the way I think about it, I would think that so the returns to human capital, I mean, to the extent that this is that the reported wage are well measured, but I would think of the human capital or the returns to human capital as being reflected in individuals' wage, and so
yes.
So this would be captured in this process here, which is going to the parameterization of this process is going to so I'm going to follow the literature, but this literature has used data on labor earnings, and so this is going to be consistent with labor income data essentially.
I see. No, my point is that the distribution of human capital is less unequal than the distribution of the rest of capital.
Yeah, I guess, I mean, I'd have to think about it, but I guess here also some debates could be exactly what is human capital and how we measure it. But
no, it's very difficult to quantify those things. But I mean, conceptually, human capital is part of the wealth of people.
Yeah. So here, the way in which I think of human capital within this model is, so individuals have some human capital and different human capitals are going to be translated in different labor incomes.
Yes, okay.
But so, sorry, Inês, you didn't really, so people own, some, like richer people own different types, people own different types of assets. But here in your model, it's all exogenous, right? So they just happen to have higher returns, and by the way, you're going to need both. You're going to need these returns to be correlated with labor income. So basically, the model, nothing is decided by the household, right? So you're not really. It's not like the household could have a choice of investing in equity or bonds if she's financially constrained, or like. It's just, it happens out of the blue.
Yes, so that's right. So let me be a little bit clear. So that's right. So I'm not going to have an endogenous portfolio decision and model that decision. So I'm going to abstract away from that still. And so let me go back to this law of motion. So the endogenous choice of individuals is going to be simply how much to consume or how much to save. So this is the only choice, how much A to accumulate. So this is still endogenous. This rate of return from the perspective of the individuals is going to be exogenous. So in a sense, I'm not going to make a stand or try to endogenize why is it that some individuals own some assets rather than others. And in addition to that, the price of these, so both labor income and returns are going to be exogenous from the perspective of individuals. I'm going to calibrate them to the data. But so individuals are not also going to be able to influence prices, but they still make the endogenous decision of, given their labor income process and their rate of return, how much wealth to accumulate over time.
Right, but yeah, sure. But then you're going to need, so these are two, can you go to one slide forward, please? So you're having two stochastic processes that are supposedly, independent, but you're going to need both to be correlated to generate the wealth distribution that you want, right? So in the end, you're kind of going to explain the data with two shocks that have to be correlated, even though, right?
So,
but anyway,
yeah, no, so actually the two shocks and the two processes are independent from each other. So the labor income shock and the rate of return shock are independent. In the cross section, then they are going to be correlated in the sense that the people that end up being rich in terms of wealth are going to be the ones that either or both received higher labor incomes and higher rates of return.
Right.
And so they have accumulated relatively more wealth over time. But this is in the cross section. In terms of the time series characteristics of the process, these shocks are going to be uncorrelated.
And how hard would it be to try to endogenize a little bit this decision? Like the fact that I understand that you need some random, so like, for example, people have different human capital, like Roger said, this translates into different earnings, labor earnings, but then how difficult would it be to kind of influence then their choice? Rich people decide to buy stocks because they are less, would it be, I think it would be nice, but it would be an endogenous mechanism explaining, the endogenous decisions to wealth.
That's right. So I think that this is an interesting question. I think I guess one of the easiest way or the most intuitive ways of thinking is saying, imagine that there is there are two assets, or for example, the Hank model. So one is more liquid than the other, but there's some cost associated with the asset that has a premium. So this would not be particularly difficult to include in this model, for example, that endogenous choice. I mean, I guess for the purposes of this model, this quantitative answer, it's not clear why would we want to endogenize that choice. It would be more realistic, maybe if you want to understand, do some policy experiments and try to understand how people shift their portfolios over time, how that affects the distribution of wealth. So I think in that case, it may make sense to endogenize or have an endogenous portfolio decision. I think it can be done. Here, I haven't done it kind of also for simplicity. And also because even in that case, I mean, one can think of different reasons why people own different portfolios, whether it's preferences, whether it's liquidity, what is it? And I mean, so I would have to take a stance on that, which I think it's fine, but it's given that here, I don't think it's strictly necessary, at least as a first step. I decided to do it in a simpler way. So here I just wanted to say one more thing, which is to point the fact that if you notice here, these functions, the mean of the process and the standard deviation have this subscript I, and this is what I mean by this type dependence. So what this is saying is that so returns might be different not only because individuals receive exposed different return shocks, but also potentially they have the mean rate of return. So the process that they face, the mean and the standard deviation are potentially different. So these are more ex ante differences between individuals. And this is what I mean by the different types.
Inês, may I check, see if I am following what you want to do? So you have these two processes for earnings and income, and capital earnings and wage, no, laboring earnings, and you have the data on the earnings. That is the table that you showed some slides before. So are you going to calibrate that data on these two processes and then see how consumption and the asset accumulation follows in the model? Is it what you are going to do?
Exactly. So let me recap. So I think it's exactly what you said. But so I'm going to have a model where their individuals face a stochastic labor income and a stochastic return process. In terms, I'm going to calibrate these two processes to the data. So the first one, in terms of labor income, I'm going to follow parameterizations that people have used in the literature. And in terms of the return process, I'm going to use the evidence, so the graph that I showed before and how returns vary along the wealth distribution. And then I'm going to say, given these two processes that are consistent with the empirical evidence on labor income and returns, how much would people endogenously optimally decide how much wealth they would decide to accumulate over time, and what would be the resulting long run distribution of wealth, and how does that compare with the wealth that we observe in the data? Yeah, did that make sense? Yeah. But so now I'm also going to discuss a little bit more on the calibration, so perhaps that will also help. Okay, so just intuitively, what is the definition of the equilibrium of this economy? So in equilibrium, there are going to be two sets of objects that I'm going to be looking for. The first one is so the policy functions, so the optimal decisions in terms of consumption and savings of individuals, which take as given their exogenous processes for labor income and for returns. And then given these optimal saving decisions of individuals and the exogenous processes for labor income and for returns, the model is going to give rise to a stationary distribution of individuals over wealth. And this is going to be also an object that I'm going to be interested in. Okay, so the parameterization of the model is going to, so I'm going to proceed in two steps. First, I'm going to calibrate some parameters externally. So here I'm going to follow standard parameterizations in the literature. In particular, in terms of the parameter that governs relative risk aversion that I set equal to 2. The earnings process, so here I'm going to assume that log earnings, so earnings in logs follow an Ornstein-Uhlenbeck process. This is just the continuous time analog of an AR1 process. And again, I'm going to use parameters in the literature to pin down or to calibrate this theta z, which is the parameter that determines the autocorrelation of earnings. And I set it such that the autocorrelation of log earnings is equal to 0.9. And the standard deviation of log earnings is set equal to 0.2. So you can think of here this process of, so earnings, the source of labor income inequality is exposed. So it's the realization of some labor income shock, and this process is very persistent. So the remaining parameters that I need to calibrate are the discount rate rho, so how much individuals discount the future, the borrowing limit, a lower bar, and finally the parameters of that govern the return process that individuals face. So in terms of well, let me start with the first two. So in order to pin down the discount rate, I'm going to, so a closed object is going to be, or a target is going to be an aggregate rate of return of 6.8% a year for the aggregate economy. And in order to pin down the borrowing limit, I'm going to use as a target in the calibration the wealth share of the bottom 50% of 1.5%. And so here, then what I'm going to be interested in is what is the distribution of wealth implied by the model within the top 50%, because by construction, I'm going to target the wealth share that is owned by the top 50. So I want to understand within that top 50 how wealth is distributed according to the model. Finally, in order to pin down the parameters of the return process, let me just say that, so I'm also going to assume that returns follow an AR1 process, or the continuous time version of that, the Ornstein-Uhlenbeck process. And the parameters that I need to calibrate, or let me also just say something else, which is in the baseline model, I'm going to have 3 types that are going to live in this economy. And so this is, well, this is kind of a formulation where these having ex post return heterogeneity and 3 return types, which are a form of ex ante return heterogeneity, this allows me to generate an amount of dispersion in rates of return that matches well the data. So precisely to pin down these parameters that govern the return process, I'm going to target these moments of the red bar graph that I showed in the beginning, which give us what is the average rate of return of different groups along the wealth distribution. So here I'm just showing how the model matches those targeted moments, those empirical moments, and here the matching or the fit is quite good. So let me then, let me also just give you this information on what are the parameters of the return process of these different types of individuals. So in the baseline economy, we're going to have that the majority, about 80% of households are going to be of type 1, or what I will call the low type. So these are households with low mean returns and relatively low standard deviation. Then there are going to be about 18% of households which are of the mid type. So these households have higher mean returns with a bit higher standard deviation as well, some higher volatility. And finally, there's going to be a small share of households, just 2%, which are of the high type. And these households are going to have substantially higher mean returns with somewhat lower volatility. And these, just as a note, these type 3 or high type agents are going to be the households that are going to end up at the very top of the distribution, reflecting the importance of these, especially these differences in mean returns over time. Okay, so let's look at the distribution of wealth implied by that model. So here,
sorry again. What do you think it might go wrong? I'm trying to understand if your model has the potential of delivering something unusual. Let me put it this way: the rich in your calibrations, they have access to assets with higher returns. The risk bigger than the risk of the consumers in the middle, but that's good, I think. And but it's about the same of the poor. So the poor, they get the same risk of the rich, and they get a significantly lower expected return. So in the end, what do you expect? More inequality. I would be very surprised if you don't have something like this. Am I missing anything here in the assessment?
Yes, okay, so let me see if I understand kind of the main point. So I guess the question is, if I have a model that has labor income and rate of return heterogeneity, can it be that this model does not generate much more wealth concentration than the simple model of homogeneous returns? Is that roughly the question? So, I mean, I guess the answer is yes, it could be. So it could be the case that, you know, let's imagine a world where, I mean, okay, let's imagine a world where wealth inequality is very high, but for some other reason that has nothing to do with rates of return. So rates of return don't matter much in practice for the accumulation of wealth. In that case, I would expect if there are return differences, but they don't matter much, then, you know, the model would perhaps generate a little bit more wealth concentration than the simple model of homogeneous returns, but not that much, at least compared to the data. Now, given that the return differences that I feed into the model, perhaps it's not surprising that this is going to generate an important amount of wealth concentration. But again, the amount of return differences that I feed into the model is the one that I observe in the data. So, I mean, it's the one that comes from the empirical evidence. So this just to say, is it, I mean, perhaps it's not surprising after observing the degree of return heterogeneity that is in the data, perhaps it's not surprising that the model generates substantially more wealth concentration, but in principle, ex ante, in theory, it need not be the case that the model generates much more or generates an amount of wealth concentration that closely matches the data, because I'm not imposing that. The model, I mean, I'm not imposing that the model matches the wealth share of the top 10% or of the top 20%. So this is an endogenous object.
Yeah, I guess another way to put it is if you had, suppose you just do a simulation without any, you just have like 100 people, you give them different wage, different capital income, and the same saving rates, and you just do that in Excel. Would you, and you get the same values that you just put in, wouldn't you not get the same result that you have with your model now? Since everything is,
and what
if everything was exogenous, like just distribute the labor income and capital income as you did, and same behavior for everyone. No maximization.
But like how? Yeah. So
it would be nice to see if the model, like we understand that indeed you did not match the wealth distribution. So it's nice that with return heterogeneity you match the data, but it's not clear what the model itself does. Like once you've said, okay, we need to take into account return heterogeneity, so that's the contribution. Then what is the model providing other than just an accounting exercise?
I mean, so the model is providing me the optimal saving rate. So if I were to do this in Excel, what saving rate should I? So I'm not.
Okay, so suppose you put the 20%. Okay, sorry. Go ahead.
No, I was just saying that I'm not matching saving rates.
Right, but suppose you put a saving rate that's constant. Let's say 20%. You match the aggregate data. How would the results differ from those you have now?
What if everyone saves at the same rate in an Excel? I mean, so the wealth share, everyone would, if they didn't have any labor income differences either.
No, they have labor income differences and they have return heterogeneity, but
okay.
They have just to kind of show a counterfactual of what the model. You know, you could do that. You could actually set a constant saving rate for everyone. Like how much of amplification the model provides, given that they have exogenous shocks, you see?
Okay, I see. So that's a good point. So I didn't do that exercise, so I don't know exactly what that looks like. But so in the model, endogenously, the saving rate is going to be higher after a high realization of the shock. So if I shut down this higher saving rates following a good realization of the shocks of either earnings and returns, then this is going to lower saving rate heterogeneity, and therefore I would expect lower wealth concentration as well. Yeah, that I could do that exercise. Yeah, thanks. So as I was showing, and I don't have much more time, so let me also go relatively fast. So here in this graph, I was showing what is the distribution of wealth implied by the model. So again, this is an endogenous object. And more precisely, what I'm plotting is the Lorentz curve. So this is showing what is the cumulative share of wealth that is going to different groups of the population. And so you can think of, so this 45-degree line reflecting a world of full equality where, I don't know, 50% of the population owns 50% of the wealth. And if we move to the right lower corner, then this would be a world of more wealth concentration, where wealth is concentration in the hands of a small group of the population. So here what I want to show is mainly how close the solid and the dashed blue lines are. And these are the solid line is the distribution of wealth implied by the model, and the dashed line is the one implied by the data. So here the main point is just saying that the amount of wealth concentration generated by this model is very close to the one that we see in the data, even though, again, I did not target directly the wealth shares of these groups. So this is an endogenous object. And so this is just saying the same thing. So then what I want to do, the last thing that I want to do is to show you what would be the distribution of wealth in the counterfactual economy, where I shut down all differences in rates of return. So this would be the homogeneous returns economy, this column here. And so in that economy, if I were to shut down all differences in rates of return, we would see that, well, first, top wealth shares would fall dramatically. And for example, the wealth share of the richest 10% would fall to about half of that of the baseline and of the data. So kind of suggesting that about half, if you want, I mean, so this is a nonlinear model, but if you want, you can think of it's about half of the wealth share of the top 10% can be explained by different rates of return beyond differences in labor income. And another way of seeing this is again through the Lorentz curve, where here I'm adding the dotted line that corresponds to this homogeneous returns economy. And again, we see that this model, and this is in line with the first, where the starting point, the first observations of the literature, where this model can generate some concentration in wealth, but still is much less concentration than what we see in the data. Okay, so let me briefly conclude.
Just a quick question. What is that substantial amount of negative wealth that is accumulated under the counterfactual?
So negative wealth would be, well, exactly that. So there are households with negative net worth. But here, so remember that I'm targeting both in this counterfactual economy and in the baseline, I'm targeting the wealth share of the bottom 50. So essentially, I'm targeting this point at which this Lorentz curve crosses here at percentile 50. So the object of interest really is how this curve looks like in the top 50, if you want.
So you're relaxing, so household can borrow in that.
Exactly. So the borrowing constraint is some negative amount, and so there are going to be some households that have negative wealth, and this would correspond to this negative Lorentz curve. Yeah. So let me briefly conclude just by saying that, so hopefully I have convinced you at least a little bit that in order to understand how the wealth inequality in the US, in particular the high wealth concentration that we see in the data, we need to consider return heterogeneity. We need to consider it first because empirically return differences are large, and this is what I document in the first part of the paper. And secondly, we need to take it into account because the implications of these return differences for the distribution of wealth are large as well. And this is what I showed in the second part, where I showed that once we include return heterogeneity in a standard model of labor income, and we include that return heterogeneity in a way that is consistent with empirical evidence, then this model is able to not only generate substantial wealth concentration, but also a distribution of wealth that is very close to the one that we see in the data, and suggests that this is a key mechanism to understand this top wealth inequality that we see in the US. So I'm going to stop here. I hope I didn't go over time, but let me just say thank you again for having me here, and I really hope to be there in person, maybe next year or the one after.
Thank you very much, Inês. Very interesting presentation.
Thank you.
Obrigada.
Até logo, Inês.
Ciao.
Tchau.
More question. Ciao, Inês. We keep in touch.